So, hello everyone. Today we are going to solve another CF problem. The problem name is yet another counting problem. So, let's read the problem statement first and then we will proceed further towards solving the problem actually. So, uh, we are reading here. You are given two integers A and B, okay, and two queries, fine. The either queries consist of two numbers Li and Ri, and the answer to it is the number of integer x such that x in the range of from L to R, Li to R, I mean, uh, and S mod A mod B not equal to S mod B mod A. Calculate the answer for each query. So this is the only thing that we need to do. So let's copy and let's move towards the whiteboard. Where the whiteboard? There it is. Hmm, loading is taking time. Hmm, yes, just waiting for the project. So it is open. Uh, why it is taking so much time? So let's see the inputs until the whiteboard is getting open. We are given one integer t, obviously the number of test cases, and the next line we are given three integers a, b, and q, where a, b are the numbers like the integers that would be used here, and q is obviously the number of queries. For that, we need to generate the output, obviously. So what we need to print? The answer of queries of this test case in order they appear. Means uh, we need to print the q integers in a single line. Here we can see that is getting printed. Uh, Means for each value of q, there would be some specific answer, and we'll keep printing till from 1 to q in a line actually. So hope the whiteboard has opened. Yes, it is. So let's erase everything firstly and then start solving this problem. Right. So uh, zoom. Let's write. Oh, we need to zoom out. X mod A mod B not equal to X mod B. Okay. So this is for what we need to solve the problem. This is the required condition. and we need to print the x that will satisfy this condition. So it's look pretty simple that we think that we would be able to generate the values for the uh like will run loop from L to R, and for the first value that would be our answer, we'll keep uh pushing it into a vector, and then after that we'll print it. But the problem is that the constraint of this problem, like here L and R varies from 1 to 10 to power 10 to the power 18, means that we won't be able to perform such iterations for this constraint. So what we need to do actually, we need to reduce the time that would be spending, like that would we need to reduce the time that the solution of this problem would be taking to get executed. So how we'll do it? So so let's look at here. There is one thing. Let me write it first, then after I'll explain everything. A plus b x mod a mod b is as same as uh, writing x mod a mod b. They both are exactly same. If you didn't understand, I can expand it. So AB mod A is simply 0, and X mod A will keep writing it X mod A and mod B. Fine. So I'm solving this part, uh, and after that we'll check that is it equal to this or not. So 0 modulo B is exactly 0. So no need to write it again. So this is the same thing. X modulo A modulo B. So what it explains? It explains that after the value of AB, the whole series of the numbers repeats. Means if we look at the test case here, if we copy this and if we paste it here and expand it a little, move it here, expand it more so that it will be visible in the video. So here if we look, this is the value of A, B and Q. So the value of AB is 4 into 6, that is 24. Means that after the 24th iteration, everything starts repeating again and again. So means instead of doing calculations till 10 to the power 18, we will be doing calculations till I is equal to 1 to 24. Either we could say, if we talk about in terms of zero, like zero based indexing, from I is equal to 0 till I is equal to 23. So that was the overall idea of this problem. Like this, that was the main idea. If you have understood this, then what we'll do further? This is the first step. And the second step would be that when we'll uh, uh, get the values for which this condition, like this one, holds true, we'll keep uh, adding these values inside an array, and these are the values that we require. So we'll keep adding it, storing it in a array, and we'll explain it in a detail while coding. But I'm just giving you the idea of the problem that we'll be using to solve further. So we'll keeping every value in the array uh, that satisfy the above condition, which I have marked here. And then after, while proceeding further, I'll I'll create a prefix sum array, and for that, uh, that would be determining the number of required elements, the desired element that we want, like the desired value of f, and with the prefix sum, while using the prefix sum, we would be able to find it in big of 1, obviously. That is the specialty of the using, that is the specialty of the prefix sum, because it reduces the PC time complexity to O of n to O of 1 when we try to find any element. So then uh, after storing everything in the prefix sum array, we'll print the answer ranging from L to R. Perfect. And one thing is more, that we'll divide everything in the uh, blocks. Let's suppose the value of AB is something like, uh, let's suppose the integer are 1, 2, 3, up to uh, wow, 24, means L is equal to 1 and R is equal to 24. So for that, we can say the value of AB is 5. So what we would be doing is, sorry. So what we would be doing here is that we're dividing this array inside a block. How the block would be, like, if the length is 5, so we'll first check that how many are full blocks. So how we can do this? The length is 24, obviously. So 24 divided by 5. There are 4 full blocks. And how many are the rest of the elements? So rest of the elements are 4, obviously. Like 24, we can do this by dividing it, like by taking the modulo, and 24 modulo 5 is 4. So what it means? that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Similarly, we'll keep moving. 16, 17, 18, 19, 20. So these blocks, like this block, so on, so on, so on, so on, this block, these are all are identical, and whatever the value of answer would be for this block, that would be same for this block. So rather than counting for each block, what we can do is that uh, we can count for one block and we'll multiply with like the number of bad elements inside one block, right? So by this we'll uh, improve the like time complexity significantly. And for the remaining elements, like that is not fulfilling the full block is 21, 22, 23. I'm talking about this case specifically 24. So these will be the identical with these numbers. Sorry, like 1 minute, like these numbers. Here. Like this box is identical. So for that, what we'll do is the rest of the elements that would get remain. So for that, we print answer for, let's say, this case. So we'll do all the calculations inside this AB length, right? Hope so you have understood the overall idea of the problem that we would be using to solve this one, like to that we would be using inside the solution. Okay, so I have already submitted the solution, but for the video purpose, I'll be coding everything once again from scratch. So this is the another problem code. So here is the code. So I'm reviewing everything here and here. So I will be coding everything from scratch again. So as the inputs, we are given int A, B, and Q. Okay. And the next thing that we are given, let me check it again, is Q. But sorry, the boundary that L2R, right? So the length for which we would be doing the calculation is A into B, and will iterate for int I is equal to 0 till I less than equal to n obviously, and I plus plus will keep iterating it. And if I modulo A modulo B not equal to, oh, sorry, not equal to I modulo B modulo A, then what we'll do is we'll create an array vector int, we'll write is at guide element, and the size of array would be length AB, that I have already told everything that whatever I'm doing I have already explained. So bag element I is equal to 1, right? We'll keep everything in long because the constraints are pretty high. Why everyone asking? I haven't closed the WhatsApp yet. Not to anyone not message. I will go somebody. So and keep the element as one, and what we needed to do is we need to we need to create a picture file, and I'm just writing the prefix array, and let's keep it long always, like everywhere. So this thing is done basically. Now what we need to do is we need to write the, like we'll be writing a solve function. So sorry, long solve, and in this we'll be giving the value of vector and array prefix array, and value of the length, value of x, and if x is negative means the range is negative, then we will be return 0, and the full blocks are x divided by length. So the now what the remaining element would be x modulo length. Fine. And after that we'll return full into prefix length plus prefix rest plus one. Why rest plus one? Because I am using, sorry, remain plus one, because I am using zero based induction. So for that uh, I need to write everything in terms of, like write everything in terms of zero based indexing. So for that I have written remain plus one. So what we need to print is out, let's write it as length. sorry, log of, I am saying length, and solve what we need to give to the function. It takes length and r minus and minus 1 solve in I have habit of saying this thing as count, count, count. So yeah, I think the code is done. Let's run this and see if it is working. Oh, sorry, it is bad. But it is getting fast. Control A, Control C, move back here, and let's submit the code. The problem is written in the function problem, Control B, and after that. I have already submitted once, but for the video purpose, I am recording everything again. Like I am doing everything again. So you're running on test case 16. Obviously, it will get accepted. So 16, 16, 16, 16, 36. Moving, moving. 60. One more time. 62. 62, 62. Running on test case number 62. And here's the green flag. Accepted. So if I talk about the problem is pretty simple. What you need to observe is how you can divide the uh like how you can improve the time, like the AB thing that I have told here. Oh, I suppose this thing you need to just observe this thing by yourself. Rest everything is pretty simple. I have used prefix sum. You can use something else. Like I have used this approach, and the rest of the elements I have did calculation as they were identical to the previous elements. So the problem I found is pretty simple. Just you need to like implement that AB idea that I have implemented. So yeah, that's all for this video. Hope you enjoyed this problem. So yeah, thanks for watching. Bye.